Gauge. Off and on switch is at the back. Machine will load up. Now once it's turned on, you don't have to change anything. It's all completely set up for you. The only thing you do if you want to change anything from one type of job to another is you adjust the amperage. The wire speed, everything else is completely preset and moves with it up or down. So it's completely taken out any of the little fiddly. On here we've set it, just to give you a bit of a rundown. Across the top here at minus 1.5 for the arc length. 45 amps you can play around with. You can go down to 29 if you want to, whatever, down to 29 and right up to 220. The next one here is set at 2. Your next one, and you, as I said, all these ones, gas flow and all that, you don't touch them. We've preset it in the factory, so you guys just pick it up and run. That's all you got to worry about. Down here, local, 0.8 wire, CUSO3, stainless steel. It's on a pulse setting, and this is your setting for that over here, and on a traditional standard stop-start torch. Okay, so everything like that you're never going to touch again. The wire we're using is CUSO3, copper silicon. The gas is argon, 99% argon. It's pure. It's not the Argo Shield 54 or anything like that. It's just straight. We attach our earth onto the job. Yep, that's it. All you do is put this on your amps and wire speed, right? That's where you'll leave it all the time. And from that you just muck around with your settings depending on your job. And then for now I'm just going to do a job where I'm going to sit in one spot, not move it, just to show you the control that you get with the machine. So I'll set that on, say, I'll go 29, and I'm just going to sit there in one spot to show you the control. You can see how long I can sit in one spot. You haven't got the big blue ring. It's a blue ring, but you know, MiG, that'd be intense and it'd be massive and hot. Whereas with that, it's quite cool and it's an easy weld. If that had zinc on it, you just paint strip that panel, you would actually see that that would have no blue ring right up to there. All the only reason that, and that's the reason you're getting MiG brazing, is to minimise the distortion to the panel. Not the distortion, sorry, the actual zinc coating not being removed. Everybody thinks, oh, it's about distortion. That's an advantage. It's not the reason why you're getting it. You got a little piece, like a little billet of steel or anything, I can just do a little weld. You got a bit of a holder on the front end and you just hold your gun there for once. You've got something where you can put your torch, which is a good thing. We'll also, that 29, I'm going to go up to 41. You'll notice what I did, it was that sort of sound. It doesn't sound good, you think, what's he doing? That's the pulse, yeah. So when you're welding, it's important that you can see better, because you can't go by your ears, because it's just a completely different sound. Affected area. This where it's been cleaned off, yeah, but right next to there you haven't got the heat. That's what MiG brazing is all about. And see the weld's nice and clean still? That's what you're after.
Yeah. Doesn't sound clean.
Like no, it doesn't sound clean because of the pulse. And it's but you can see the result is like, oh yeah, but that's because what happens with pulse synergic is the weld, instead of the old days where it's just dip transfer, like the end of the wire is just dripping off, what's happening is it goes down, pulls back and then sprays. So at the end of the wire, it's just spraying the bit far more small pulses. Yeah. That's the sound difference you're getting. We'll put it on 34. So the other one I was doing at 41. Yes. Right, I do a plug weld at say 50. This I'll do at 34. Maybe I'll cut back to 29. We'll just play around with it. So first what I'm going to do is do my tacks every say centimetre and a half. Then we'll sand that off and then we'll do our weld. Alright, so just do that to hold the panel so it's all going to stay nice. Right, this is the way I do a quarter panel joint, so I try to mimic exactly the same thing, a good idea. And pulse it all the way, non-stop. So you'll notice there's virtually no sparks. Really clean, and you get a nice flat weld like that.
Just quite like doing those spots.
Yeah, I'm just doing it like that. Now, sometimes think brazing, it's zoop, straight across. You can in some cases, but why I do that is you get a really nice layover weld, you get a really good penetration, and it's a clean weld. So you see that the weld is almost like TIG, it's like that little button wash that's shown on top of it. That's a good strong weld. You've got the heat is minimised to a heap, and I do that on my quarter joint. So what do I do? Once I've tacked it, I don't weld 2 centimetres, stop and cool off, weld it and stop. I'll do
Right across.
yeah, pulsing, and you cut your distortion down heaps.
Well, nice.
Cool, eh? And I feel that. Feel your torch. So now, just to show you the strength, some people worry that it's not as strong or whatever. Let me just show you. Really distorted any of it.
No.
Right? After a heap of hits, slight little crack just there.
Yeah.
That's it.
Which you wouldn't need.
Mate, you wouldn't. No accident is someone going smack. It's one hit. Alright, so you can see the strength of it, you can see it's easier, it's a quicker sand job. So when you're doing your quarter panel joint, okay, on a corolla, like that, I would do a joint, I'd put a filler piece underneath it, leave a 2 mil gap, and then just fill that piece, and you'll get virtually no distortion. It's nice, isn't it? I was on 34, now we're just going to go to do a plug weld. I'm going to go up to 51 or 53, either one of those is fine.
Yeah, let's say you've got a hole like that, through the hole.
Yeah.
Let's just fill it up. Yeah, I can fill it down. Or I can just do this.
That one is still put
Silicon roll.
I moved to Sydney 12 years ago.